So we started this AP problem in our previous notes on mean value theorem. Now let's get into part B. First, they want us to show that g prime of 2 equals g prime of 5. So let's just start by focusing on that first. So g prime of x, we're going to use this function defined here for g of x. So its derivative is f prime of f of x times f prime of x using chain rule. So g prime of 2 is f prime of f of 2 times f prime of 2. Well, f of 2 is 5, so that's f prime of 5 times f prime of 2. G prime of 5 is f prime of f of 5 times f prime of 5. Well, f of 5 is 2, so that's f prime of 2 times f prime of 5. Using the commutative property and transitive property, we can show from this that g prime of 2 equals g prime of 5. First part is done. Now they want us to use this result to explain why there must be a value for k between 2 and 5 such that g prime of k or g double prime of k equals 0. Anytime you're trying to show that a rate of change is equal to 0, you should be thinking Rolle's theorem. You could also use mean value theorem, but Rolle's theorem is explicitly used for showing that your rate of change is equal to 0 somewhere in the interval. So remember, there are 3 parts to Rolle's theorem. The first part is to show that your function is continuous. How do we know that g prime of x is continuous? Because notice we want g double prime of x. So we know g prime of x is a composition of f and f prime, which are differentiable. So g prime of x is differentiable, which implies that g prime of x is continuous on the closed interval from 2 to 5. That also shows us that g prime of x is differentiable on the open interval from 2 to 5. We also just showed in our previous step that g prime of 5 equals g prime of 2. So by Rolle's theorem, there exists a k value, an element of that open interval 2, 5, such that k double prime, misspoke, such that g double prime of k equals 0. So notice, since we were trying to show that the second derivative was equal to 0, we were always using the first derivative in our 3 steps to use Rolle's theorem.